welcome back. Today we're going to talk about comparing fractions and mixed numbers. Now, you can use models to compare fractions. Sometimes it's not always the easiest thing, but let's kind of look at how it works. If I'm going to compare 2/3 and 3/4, first I need to divide my model up. And you can see already the problem with this task is that we can't really divide them as equally as we'd like. And so you start to get the feeling that it's just really hard. I mean, look, if I'm going to try to divide this up, look at what happens. And I'm going to divide this one in fourths. Okay. And when I go to shade it, I've got 2/3 and then 3/4 here. Okay. And so comparing these fractions visually, it looks bigger, but did I divide it evenly? I don't really know. And so one of the things that we're going to do to try to combat this is to think about it in terms of comparing them with things that are the same. What do I mean by that? Well, if I can compare things based on the same units. Now this is pretty messy, but you're going to kind of get the idea. What I'm going to do is I'm going to divide it into a certain number of parts. I'm going to pick 12 parts here. Okay, so I have 3, 6, 9, 12 parts. And over here, I'm going to have 12 parts as well. Divide it in half, half again, half again. Now watch what I shade this time. 2/3 is really equal to 8/12, because if I multiplied the top by 4 and the bottom by 4 as well, I would end up with 12ths. And 12ths are good because they allow me to compare things side by side. So 8/12. So I'm going to shade 3, 6, 7, 8 of these. Now over here I have 3/4. And if I multiplied both of these by 3, I'd have 9/12. Well, you see immediately what happens here. Which one of them has more? Well, upon visual inspection, I wouldn't necessarily know, except that I know that 9 of them are shaded here and 8 of them are shaded here. Did I need to do that visually in order to compare these? No. But you kind of see the downfall and the upside. Let's compare fractions. Example 1. Compare 3/8 and 5/12. Well, really, what I'm going to say is sometimes you want to find the least common denominator. Sometimes you just need to find something common. So for me, I look at 8 and 12, and I think to myself, okay, if I could list out some multiples of 12, I could also list out some multiples of 8. 8, 16, 24, 32, 40. Okay, and I just need to find something common. I see this 24 here and the 24 here. Just happens to be the least common. Those are the things that come to mind first. So 3/8, and we want to go to 24ths. So let's look. 3/8. Well, I need to multiply 8 by 3 to get to 24, so I have to multiply the top by 3 also. Multiply the top and the bottom by the same thing. Look what I get. 3 times 3 over 8 times 3. Well, normally I'd want to cross these out, but I'm not trying to make it small. I'm trying to make it bigger so that I can compare it. And so I end up with 9/24. That's the first one. Second one, 5/12 to 24ths. And so I'm going to say 5/12. And what times 12 equals 24? Well, that's going to be 2. 5 times 2 over 12 times 2. Once again, normally I'd cross out to make it smaller, but I don't want to make it smaller. I want to make it bigger for comparison. And so this is 10/24. And which one's bigger, 9/24 or 10/24? Well, obviously, 10/24 is bigger, which was my 5/12, so this is bigger. I'd like for you to do the same thing for B. So this I have 3 and 8 as my common denominator. I'm thinking list out the factors or list out the multiples and try to find something that small that goes into both. I'm going to do C as another example. C is another example. So I have 10 and 4, and so I'm going to list out some multiples of 10, 10, 20, 30, 40, and some multiples of 4, 4, 8, 12, 16, 20. You can do this in your head. I'm just saying this is something that helps me. What I'm going to show you though, yes, 20 is the smallest one, but even if you didn't know what the smallest one was, you could always just pick the product of the two denominators. And so I'm going to pick 40. 3 over 10, 2 40ths. Because we can always get a common denominator by multiplying the two denominators together. So if I'm going to 40ths, 3 over 10 times, and that's where this 4 comes in, 4 over 4 equals 12 over 40. And my other one is going to be similar, 2 over 4 to 40ths. And so now that's where I'm going to use the 10, so 2 over 4 times 10 over 10 equals 20 over 40. Well, upon inspection, you really see here, we've got quite a stark difference, 20 over 40. So 2 over 4 is actually the bigger one in this case. Do the same thing here. Now, you don't necessarily have to multiply the denominators together. Might be a good idea in this one. Ordering fractions. Well, ordering fractions is pretty much the same thing. We're just deciding which one's bigger, except there's multiples of them. I'm going to show you how to deal with something like this. Here's the key. Mixed numbers. What? What do we do with that? Well, we're going to take mixed numbers and make them improper, meaning bigger on top than on bottom. Well, this is what that looks like. So 4 and 7 over 16. So I'm going to do around the horn, the C method. So 16 times 4 equals, now that's 4 times 10, which is 40, plus 6 times 4, so 64, plus 7 over 16, 71 over 16. So this is 71 over 16. Here I've got 19 over 4. Well, I'm going to look at my other fraction. I've got 16ths, 4ths, and 8ths. So we're going to 16ths because all of those numbers go into 16. So that's my first one. My second one is going to be 19 over 4, and I'm going to 16ths. So 19 over 4 times 4 over 4 equals, now, here's another little multiplication trick. 19 is almost 20. So I'm going to do 20 times 4, which is 80. Well, then I have to take 4 back because I multiplied it by 4, so I have 1 less. So that's going to be 76 over 16. Next one. Going in this aqua color. 35 over 8. Well, I'm going to 16ths. So 35 over 8 times 2 over 2 equals 70 over 16. Which one's bigger? Well, because I found that common denominator, is 71 bigger, 76 bigger, or 70 bigger? Well, I'm going to order them like this. 76 over 16, comma, 71 over 16, comma, 70 over 16. But unfortunately, that is not what the choices were. I don't see those choices anywhere. So I have to match them up. This is 76 over 16, which is my middle one, which is my 19 over 4. 71 over 16 was my first one, which was 4 and 7/16. My third one was my 35 over 8. That's ordering them. I'm finding the common denominator so I can compare them based on something that is real to me, something that really means something. Complete with less than, greater than, or equal to. Well, I'm doing the same thing here, guys. I'm looking at the 5. I'm looking at the 3. I'm thinking 15ths. So 16 over 5. I'm going to 15ths. 16 over 5 times 3 over 3. I know that's 15 on the bottom. And I've got 3 times 10, which is 30, plus 3 times 6, which is 18. So it's 48 My next one is 3 1/3 15ths. I'm going to convert first, so I've got 3 times 3 plus 1 over 3. 10 over 3, so I did 3 times 3, which was 9, plus 1 was 10. 10 over 3 times 5 over 5 to get my 15ths. And you see upon inspection which one is bigger. So I've got 50 over 15 versus 48 over 15. Oops, I went in the wrong order. 48 over 15, underline 50 over 15. See, because they go in order here. So it's going to eat the bigger one, so it's going to be 3 1/3. That's all there is to it, guys. Find that common denominator, and if all else fails, use the multiplication problem, the product of those two denominators. Thanks for watching. We'll see you next time.